This is an example of a limiting reagent problem for stoichiometric math. So what we have here is methane gas being burned in oxygen to produce CO2 and water. And the question is going to be something like, if I start with 25 grams of methane and 25 grams of oxygen, what's going to be left in the container after the reaction has been completed? And so since this is a stoichiometric problem, the first thing we're going to need to do is balance. The carbons are already balanced. There's one on each side. On the right-hand side, I've got 3 oxygens, and on the left, I only have 2. So I'm going to put a 2 here. That way I can also balance out my hydrogens, and that makes my oxygens an even number. So I've got 4 and 4, and then here's 2, and then here's 2, so 4 oxygens. So I put a 2 in front of this oxygen on this side, and the whole thing's balanced. Alright, so then I'm going to need to do 2 calculations. I'll use the railroad track method. So I've got 25 grams of methane and 1 mole of methane. So the gram number for this methane is going to be the mass off of the periodic table. And just a second, I'll get that. So the mass of a carbon is 12.011 grams per mole, and hydrogen, so I'll add that to 4 times 1.00795. So I get a mass of 16.0428. Okay, so what this first step does for us is, this is a mass of methane, and then this is a number of methane molecules in terms of moles. So we basically just counted the methane molecules in 25 grams of methane. So I'll keep going with this. So I don't care exactly how many methanes there are. What I want to know is what's going to be in the container. So we're going to see how much, say, water this makes. And so I'll put 1 mole of methane down here, and then 2 moles of water up top. And what this next step says is, for every this number of moles of methane, I get to make this number of moles of water. And so whatever my methane, since it's a 1 to 2 ratio, that's where this 1 and this 2 came from. So that 2 is that, and this 1 is that. But since I can't count water molecules, what I'm going to do now is figure out how many grams that is. So 1 mole of H2O, and then it's 1.00795 times 2 plus 15.9994. And so then this is 18.0153 grams of water. Alright, so then this is going to be a number of grams of water. So 25 divided by that 16 number times 2 times my 18 number, and I get 56 grams. So what this is saying is, if I start with 25 grams of methane and I have as much oxygen as I need, I can make 56 grams of water. Okay, so now we need to do it for the other reactant, because I don't know actually if I have enough oxygen to burn all of this methane. So let's calculate that out. So this time we'll start with 25 grams of O2, 1 mole O2, and then that's 31.9988 grams of O2. And then for every 2 moles of O2, I make 2 moles of water. So I need to make sure that I go to the same endpoint. So in this one up here, I was looking for the amount of water. In this one here, I'm going to also need to look for the amount of water. That way I can determine which one is a true statement. And then for every 1 mole H2O, 18.0153 grams H2O. And then this will be grams of H2O. And so let's see what that's going to be. So 25 divided by 31.9988 times 18.0153. And the 2's cancel out. So then it's 14. Okay, so what this means, since this is the smaller number, it means my oxygen is going to run out first. So my oxygen is my limiting reagent. So if I put 25 grams of each of these reactants in a container together, my O2 will run out. And the moment my O2 has run out, I will have made 14 grams of water. So what I know right off the bat here is when this reaction is done, I'm going to have 0 grams of O2. I'm going to have 14 grams of water. Now let's figure out how many grams of CO2 are going to be made. So 25 grams of O2, 1 mole O2, 31.9988 grams of O2. It was 2 moles of O2 for every 1 mole of CO2, 1 mole of CO2, and then it's got a 31.9988 plus 12.011, and so then this is 44.0098 grams of CO2. Okay, so 25 divided by 31.9988 divided by 2 times that 44 number, and so I get 17 grams of CO2. Okay. So since this is just a four-piece problem, so actually let me add that, 17 grams of CO2. Okay, so 25 grams goes in, 25 grams needs to come out with leftover. Sorry, 50 grams goes in. And so there needs to be 50 grams on this side over here. And what I have is 31 grams of product. So I've only made 31 grams of product. So what that means is, since 50 grams went in, 50 grams goes in, and I've only got 31 grams of stuff made, so that means there's 19 grams of leftover stuff, and the 19 grams of leftover stuff is my unreacted methane. So in my container, I also have 19 grams of methane gas. So the answer to this question would be 19 grams of methane gas, 14 grams of water, and 17 grams of CO2, and 0 grams of oxygen.